Sorry, let me click around here for a minute. All right. Well, my face is red. And as a matter of fact, I woke up um, this morning about 3:30 and went, I screwed up that calculation for you guys. And so I'm going to do it on this Barabbas TKR here. Let's try guessing that horsepower one more time. Okay, so I'm going to put it on the screen here, and here's the specs for it. So let me write down what the mass is. The mass is before we get started, 1,230 kilograms. The time that it took was 1.67 seconds, and the speed that it's going. You know what? Maybe I should probably use, since it's going from zero. No, because I'm doing a mass times acceleration, getting the force, and then doing the speed. I should maybe do the average speed, possibly, but that would probably be better since it's under a yeah, because the average speed for him to go that distance. So we'll use the average speed of 30 miles per hour. Okay, so here we go. So I'm going to use the so I'll use the average speed of 30 miles per hour. And because I forgot to, when I changed it to horsepower, I forgot to multiply by the 0.00134 for one watt is equal to 0.00134 horsepower. Okay, so let's take a look at this. All right, so let's calculate its acceleration, but its acceleration I'm going to say is constant, but I'm going to give it as its speed when I take force times velocity. I'm going to do the average speed from 0 to 60. 0 plus 60 is divided by 2 is 60, divided by 2 is 30. All right, so I wouldn't believe what I'm saying right now, but I'm just going to go out on a limb here and see if we can pull this off. Waiting for the ladybug to turn on. There it is. There's the things we just talked about. All right. So the other thing, I had a student, not from this class, but from another class, say, hey, I can't see what the heck you're doing. So I'm going to see if that helps. I got to click it over here. Okay, and that looks like it might be better. That might help students who are having trouble seeing. So, all right. So anyway, here we go. So we're going to take the acceleration we've got to calculate, which would be, because it went from 0 to 60 in that amount of time. Well, we know that 60, when I calculate, sorry, I don't have my calculator out yet. I got so excited, I just wanted to come in and do this real fast. Also, I have a student coming in about 10 minutes, so I want to get finished. So 0 to 60, so 60 times 0.447, 26.82. So V final is 26.82 meters per second. All right, and V final minus V initial divided by the time gives me the acceleration. So divided by 1.67. Yeah, 16.05 meters per second squared. And we're going to assume that's a constant acceleration over that amount of time. All right, and so the F is equal to ma, and then power is equal to ma times v, which is a funny thing to me because we got meters, but that'll work. That'll work because it's a force times velocity, and so we've got 1230 times 16.05. Now, what we're going to use is we're going to use the average velocity times 30. Oh, but I got to change the 30 to 13.41. So the average velocity is 13.41 meters per second. Where did I get that? I cut that in half. times 13.4. And that should give me the joules. So it's 1230 times 1605 times 13.4 equals this huge number. Huge number. All right? 2.6 megawatts. Well, let's multiply that times 0.00134 and see what happens. I forgot to do this little. That's still 35,000 horsepower. That still doesn't make sense to me. That still does not make sense to me. Okay? I just don't get it. But again, let's take, so let's try another. And so I wound up with 35,447. Now for our other problem, it worked out fine. It's this acceleration that's bugging me. 0 to 60, 1.67, 35,000 horsepower. That's just impossible. Okay? So let's look at this. And I may not even record this. Anyway, so we get 1/2. So if I take 0.5 times 1230 times 26.82 squared divided by 1.67. Okay, now this is starting to make more sense. When I take the kinetic energy, when I take its final kinetic energy at 60 miles an hour, I get 442,377 joules. Okay, and then when I divide that by 1.67, I'm starting to get numbers that are starting to make sense. When I multiply that by 26,000, I get 264,896. And when that's the watts when I divide this by the time, because that gives me the watts. And now when I multiply that, that's only 354 horsepower. I know it's got 3 times that horsepower. So somewhere between, so I'm getting so somewhere between 35,000 and 354 is the right answer. Might be 3,000 horsepower. I don't know. Because I do know that it almost doubled the acceleration of the. I think I need a more general accelerator. I think what's messing me up here is the acceleration. But anyway, I just wanted to kind of show you how we do science and stuff, and how we start thinking about stuff, and how it wakes us up in the middle of the night when we've told students we think is a wrong thing. But I'm kind of stumped on this. It sure did work out in the other video when we go through the problems. All right, okay, on your homework. All right, out here.